A spread spectrum. In digital communication, the efficient utilization of the bandwidth and power are the two major factors. In some situations, it is necessary to sacrifice this efficiency, the transmitter signal is not easily detected by the unauthorized users. This requirement is achieved by a signaling techniques called as spread spectrum modulation. So the spread spectrum modulation is required to provide a secure communication in the hostile environment, that is military applications, military communications like that. So first, the definition of a spread spectrum. In spread spectrum modulation, a modulated signal is modulated second time in such a way to generate a wideband signal. First, we can generate the narrowband signal. The second modulation, we generate a wideband signal. This is the definition for spread spectrum. The spread spectrum means a transmission in which the message sequence occupies a bandwidth in excess of the minimum bandwidth necessary to send it. So the spreading is achieved by a code, that is PN sequence, that is pseudo noise sequence, which is independent of the message sequence. The same code, the PN sequence, is used to receiver to despread the received signal so that the original message sequence may be recovered. The spreading is accomplished before the transmission. The advantages of spread spectrum is it provides a secure communication and its ability to tolerate a considerable amount of signal interference, and it has the ability to reject the intentional interference by a transmitter attempting to jam the transmission. In wireless communication, it increased capacity and spectral efficiency, and also the several users can independently use the same higher bandwidth with a little interference. It has the ability to reject unintentional interference by another user simultaneously attempting to transmit through the channel. Next, the disadvantages are multiple access interference is present and very poor bandwidth utilization. So these are the disadvantages of the spread spectrum. Next, the applications. So the applications of a spread spectrum, it is used in a satellite communication. It can be used for multiple access communications, and also the spread spectrum signals can be used for ranging or determination of the position of the location, and it is used in a satellite communication and local area networks also. This is the general model of the spread spectrum communication system. First, the data input is fed into a data encoder, so that will produces the encoded output. The encoded output is applied into a spread spectrum modulator. This some data sequence code will generated by using the pseudo noise code generator. This code is called a spreading code, so that will apply into a spread spectrum modulator. The output of a spread spectrum modulator is having the signal having a high bandwidth. So initially the encoded output is the bandwidth is the signal of the bandwidth of the signal is relatively narrow bandwidth, but the modulator is a spread spectrum modulator output is the signal having a higher bandwidth. Then this signal is in the receiver side, we have a spread spectrum demodulator that will the spreading code is used to demodulate the signal. Then this signal will apply into a data decoder to recover the original data from the signal. From the output signal, we can recover the original data. So the pseudo noise sequence, the PN sequence, means a periodic binary sequence with a noise like waveform that is usually generated by means of a feedback shift register. The same code is used to in both the transmitter and receiver for a particular user for spreading and despreading. This code is called PN sequence code. This is the PN sequence generator. So a shift register of M flip-flops will have a 2 power M number of states. The output will repeat itself after 2 power M bits. To generate the PN sequence, assume the initial state of Q2 and Q3, Q2, Q1 to 110. The output Q2 and Q3 are connected to a modular 2 adder. The duration of every bit in the PN sequence is known as chip duration, and the chip rate RC will be defined as the number of bits per second, that is RC is equal to 1 by TC, and the period of a pseudo noise sequence TB is equal to N into TC. The period of a PN sequence will be produced by a linear feedback shift register with M number of flip-flops cannot exceed 2 power M power minus 1. When the period is exactly 2 power M minus 1, then the PN sequence is called a maximum length sequence or simply M sequence. This is RC, that is chip rate, and the period of pseudo noise sequence TB is equal to N into TC. Then the properties of these are the three properties of material length sequence, that is PN sequence, having three properties, that is balance property, correlation property, and run property. The balance property, it's having good balance requires that in each period of the sequence, the number of binary ones differs from the number of binary zeros by at most one digit. This is called a balanced property. Next, run property. The run is defined as a sequence of a single type of binary digits. That is, the appearance of the alternate digit in the sequence starts a new run. That is the length of the run number of digits in the run. Among the runs of ones and zeros in each period, it is desirable that about the 1/4 or of the length of 2 or 1/8 or the length of 3. So such as it will goes on. Then the third property, that is the correlation property. If a period of a sequence is compared the term by term with any cyclic shift of itself, it is best if the number of agreements differs from the number of disagreements by not more than the one count. This is correlation property.